Hi, my name is Caitlin Green, and this is my part 2 of the Chapter 8 Textbook Problems. Like I said, part 2, so there is one before this. So make sure you watch that, and yeah, let's go ahead and begin. Starting off with number 6, it says 7 female executives in a large corporation contend that they are being discriminated against in terms of salary. Their salaries in thousands of dollars are 31.3, 29.5, 27.4, 28.7, 29.4, 29.0, and 30.7. So the X bar of their salaries for the male executives is 31.4. Using an alpha of 0.05, make a decision about the women's charge. So, as we can see, we have an N of 7, and the male mu is going to be 31.4. And we know that we need to be able to compare the two mu's, so our null hypothesis is going to be X bar is less than or equal to mu of the male, or X bar is greater than the mu of the male. And this is a problem that's kind of easy to get confused about just because it seems like there's no direction, because it just says make a decision about the woman's charge. However, they are saying that they're being discriminated against, which would insinuate that they do have a lower average salary than the males do. So we know that we're going to have a one-tailed task because we are going after a less than value. So we will be doing a t-test on this one, and our equation is going to be x bar minus mu divided by the standard deviation of the x bar. So we know that the female X bar is going to be 29.429 or 4.3 if you want to round it. We know this because we added up all their salaries and then divided by 7. And then we have to find the standard deviation, which I got was 1.288 or 1.30 if you want to go ahead and round. And to find the standard deviation of the X bar, we have to take the standard deviation and divide it by the square root of n, which in this equation is 7. So we will get a standard deviation of X bar to be 0.487 or 0.49 or 0.5, whatever you want to do. So now we're going to take that and put that in our equation. We're going to have 29.43 minus 31.4, divide that by 0.487 to get a t-score of a negative 4.45. And we now need to find t-critical, and since we're doing t-scores, we're going to be on table 7, and I find that t-critical to be 1.943. And the absolute value of tcal is greater than 1.943. So our decision is going to be to reject the null hypothesis and accept H1, which means that the women are correct and that they are receiving significantly lower average salary than the males are in that company. And so therefore they are correct in that they're being discriminated against. Moving on to number 7, I'm sure my point by serial looks really weird. I was trying to read it from the textbook and I couldn't seem to make it bigger, so I'm sorry if it's unnecessarily weirdly formatted, but hopefully it'll be the same thing, just I guess look a little weird. But it wants us to find the point by serial for problems 1 and 2. So we will take, the equation is going to be RPB is equal to the square root of t squared divided by t squared plus the degrees of freedom. And we know that tcal from problem 1 is a negative 1.95, and we know that tcal from problem 2 is a negative 2.06. So this is all pretty simple just to put in. You'll just put in your values for number 1. So you'll have the square root of negative 1.95 squared divided by negative 1.95 squared plus 22. And we'll end up getting a value of 0.384 for the point by serial for number 1. And then for number 2, following that same setup, we'll get 0.402 for that value. I'll go ahead and briefly show it to you here just so you can see how that thought process looks like. It's very, very simple in comparison to some of the other questions I felt like. Now moving on to number 8, it says what percentage of the variabilities in the numbers of headaches can be attributed to the treatments in problems 1 and 2. So in finding the percentage of variability, we're just going to take r squared and multiply that by 100, which I'm pretty sure comes from chapter 5, if I'm right. Maybe it might have been the last chapter. I've slept a few times, but it's another pretty easy question. We'll just take, say for number 1, we'll take the 0.384 squared and times it by 100 to get a percentage of 14.75. And for number 2, we'll take 0.402 squared multiplied by 100 to get a percentage of 16.16. And as you said in your videos online, you can go and look, and the square rooted value of the point by serial that we did in the last one is actually going to be very close to the percentage of the percent of variability before you square root it. Just a little tiddly bit of information, I guess. Going on to number 9, it says the scores for 10 students in an advanced math course on the midterm and final examinations are presented here. In both tests, 100 points are possible, and then it asks, did a significant change in average performance occur in either direction? And so since it says either direction, we know that it's going to be a two-tailed test, and we have an alpha of 0.05. So just to go ahead and set up the first part of our hypothesis, we'll have a null hypothesis of mu d is equal to 0, and then we'll have a alternative hypothesis of mu d is not equal to 0. We have an alpha of 0.05, and so now we need to find the t calculated value. And the equation for this one is the t equals the d bar minus the mu of d, which, as you said in one of your videos, if it's like a true value, it should be equal to 0, if I'm correct. And so really it's just kind of like d bar divided by the standard deviation of d bar. So on the midterm, we knew that we had a x bar of 7.51 and a standard deviation of 14.88, and we had an n of 10. And on the final, we had an x bar of 76, so not really that much improvement from the start. A standard deviation of 15.56, and then, of course, the value is still 10. And the reason why we needed all these extra values is because we need to find the di values. And we found that x bar is a negative 0.9. The standard deviation is 2.96. And then, of course, n is still 10. Brain can't do math today, I guess. Or I guess I just can't read because I already did the math. But anyways, we're going to take all of that and put that into t. And our t equation is going to look like t equals a negative 0.9 minus 0. You really don't have to put that, but I did anyways just to have a bit more just equation accuracy. And then I divided that by 0.936. So I ended up getting a t calculated of a negative 0.96 and an alpha of 0.05. And we obviously have to go on to our t table or our a table to find what T critical is going to be, and I got that T critical was 2.262. So our decision is going to be fail to reject HO. And what that simply means is that there is not a significant difference in the average performance between midterms and the final exam. So I guess the students either didn't prepare enough, had a bad test, or they didn't learn anything in between midterms and finals. Now we're on to number 10, and it says find the 99% confident limits for mu1 minus mu2 for problems 4 and 5. So the x-bar value for question 4 was 10.75, and the x-bar value for number 5 was 9.73. And it's quite a long equation, but to find the confidence limits, we have to have mu1 minus mu2 is equal to x bar 1 minus x bar 2 plus or minus sigma x bar 1 minus x bar 2 multiplied by z critical. And what that all ends up looking like is we're going to take 10.75 minus 9.73 plus or minus 0.4, which was our sigma x bar 1, x bar 2 for, I believe, problem number 5. And we're going to multiply that by a z critical score, which by doing that we just go look in column C of, I believe, table D, if I'm right. Just going back and looking for the z critical value of 0.005 and finding what z cal would be, which was 2.57. And so we know that it's going to be equal to 1.02 plus or minus 1.03. So we ended up getting an answer that looked like negative 0.01 is less than or equal to mu1 minus mu2, which is less than or equal to 2.05. Now we do something similar in question 11, as in we're looking for the 95% confident limits for the population mean of the women in problem 6. So to find the confidence limits, we take the mean or the means plus or minus the variance of, or the variance times the critical score. So it looks like x bar plus or minus the standard deviation of x bar multiplied by a alpha of 0.05, just because that was our alpha in that problem. So we have 29.43 plus or minus 0.4875 multiplied by 2.447, and we get a confidence limit of 29.43 plus or minus 1.193. So that ends up giving us a final answer that looks something like this. All nice and highlighted, so it's a bit easier to read. And we get 28.24 is less than or equal to the mu of the women's average salary, which is less than or equal to 30.62. So what this would mean is that that with 95% confidence, the true mean salary for the women in the company falls somewhere in between 28.24 and 30.62 thousands of dollars. So this has been part 2 of my Chapter 8 textbook problems. I apologize for all of my tongue twisters today, but hopefully everything made sense, and I really appreciated that you watched. Have a good night, and stay tuned for Chapter 9.1's textbook problems. Thanks.